The Haber process is an industrial method used to produce ammonia, a key ingredient in fertilizers, from nitrogen and hydrogen. Nitrogen is abundant in the air, making up about 78% of the Earth's atmosphere, but it is relatively unreactive and difficult to convert into compounds plants can use. Hydrogen, on the other hand, is typically obtained from natural gas or through the electrolysis of water. The Haber process combines these two gases under specific conditions to create ammonia, a compound that is essential for agricultural productivity. In the process, nitrogen and hydrogen gases are pumped into a reaction chamber, where they are subjected to high pressures, around 200 atmospheres, and heated to temperatures of approximately 450 degrees Celsius. A metal catalyst, usually iron, is used to speed up the reaction. Under these conditions, nitrogen and hydrogen react to form ammonia, NH3. However, the reaction is reversible, meaning that ammonia can also break down back into nitrogen and hydrogen. Because of this reversibility, achieving a high yield of ammonia requires carefully balancing the reaction conditions. One challenge in the Haber process is finding a compromise between temperature, pressure, and the speed of the reaction. Higher temperatures make the reaction proceed more quickly, but since the reaction is exothermic, meaning it releases heat, higher temperatures also favor the reverse reaction, where ammonia breaks down into nitrogen and hydrogen. On the other hand, lower temperatures would favor the production of ammonia, but the reaction would be too slow to be practical on an industrial scale. Similarly, increasing the pressure favors the formation of ammonia, but high pressures are expensive and difficult to maintain. The compromise in the Haber process involves using moderately high temperatures and pressures to produce ammonia at an efficient rate, even though this means some of the nitrogen and hydrogen will not be converted and will need to be recycled through the system. Typically, only about 15% of the nitrogen and hydrogen gases react to form ammonia on the first pass through the reactor, but the unreacted gases are recirculated, which increases the overall yield. The Haber process is a crucial innovation because ammonia is essential for producing nitrogen-based fertilizers, which have greatly increased global food production. Without this process, it would be nearly impossible to sustain the agricultural output needed to feed the world's growing population. However, the process is energy-intensive, and because hydrogen is often sourced from fossil fuels, it contributes to carbon emissions. This has led to ongoing research into more sustainable methods of producing ammonia, such as using renewable energy sources to generate hydrogen. Despite these challenges, the Haber process remains one of the most important chemical processes in the modern world.